What is a vector space? A vector space, usually denoted by capital V, is a set of independent vectors with two operations, vector addition and scalar multiplication. These two operations must adhere to a list of axioms in order for your set of vectors to be considered a vector space. So here's the list of axioms. I'm not going to read them out loud for time constraints. You can pause the video, write them down, and study them as you please. So let's take a look at vector addition and scalar multiplication, are two operations. So this first one is vector addition. We have two vectors, u and v. And let's keep in mind that a vector is really anything with magnitude and direction. It's just best represented as an arrow. So take, for instance, driving a car. Say you're driving 10 miles an hour east. The 10 miles an hour is the magnitude. East is the direction. So here we're just going to use arrows again. And we have two vectors, u and v, and we add them together, u plus v, to yield this diagonal line. The dotted lines complete our vector space. And essentially our vector space is any combination of u and v that lives inside this space. So scalar multiplication is then multiplying one of the vectors, or both, by some scalar. Here we use 2. We did 2 times u, same u. You extend, you go 1, 2, multiply it by 2. And then we draw our diagonal line again, 2 times u plus v. And we get a new vector space with new sets of vectors that can exist inside this space. And really, this one had scalar multiplication. The scalar was just 1, so you didn't really see it. It was not necessary to put it in there. And here's an example of a 3-vector space, w, v, and u. And you can kind of draw that out and play with that and look at the combinations of vectors inside this space. Thanks.